going to identify and compare numbers in the real number system and solve equations by finding square roots or cube roots. Identify and compare real numbers. Now let's recall that rational numbers are numbers that can be written as fractions. Example, rational numbers are given below. 1 and 2/5 is 7/5. These are all rational numbers. -4 is -4/1, or 1500th, you see that? -3 bar notation is 1/3, or sorry, that was not negative, it's just 0.3 bar notation. And then square root of 25 is 5/1, right? Irrational numbers are numbers that cannot be written as a fraction. When written as decimals, irrational numbers neither terminate nor repeat. They will not terminate, they will not end, and they will also not repeat or follow any kind of pattern. So a key concept is that irrational numbers are numbers that cannot be expressed as a fraction, a over b, where a and b are integers and b cannot equal 0. It cannot be expressed like that. For example, pi, the symbol pi, is an irrational number. Okay, the decimal does not terminate, does not follow a pattern. And negative square root 5 is also an irrational number. It's an approximate decimal place, as you see right there. Okay. When we talk about irrational numbers and rational numbers together, the whole set together make up the set of what we call real numbers. They are all real numbers. The diagram shows the relationship among the real numbers. And here we have it. Okay, so real numbers, as far as we know, we've worked with natural numbers, and then we added the whole numbers, and now we have the negative for integers, right? And then we added anything that can be expressed as a fraction, percent, and so on, okay, or mixed number, and those were all rational numbers. And now we're going to add this section on this side of irrational numbers, numbers that do not terminate, decimals that do not terminate or follow any repetition or pattern. Okay, something to know is that when we're computing, when we're factoring or multiplying, dividing, when we're computing computations with an irrational number and a rational number other than 0, produce an irrational number. So you can be working with a rational number that can be converted into a fraction, but as soon as we work with an irrational number and a rational number, it will turn it, the product will be an irrational number. For example 1, let's become familiar with numbers. Name all sets of numbers to which real numbers belong, right? Natural, whole, integer, rational, or irrational. 21/7, when we divide 21 by 7, we get 3. And 3 is a whole number. Okay, it's a natural number too. 1, 2, 3, 4, 5, natural number. It's a whole number. It's an integer, and it's a natural number. So this one is, it's a natural, it's all 4. When we have b, -2.5, it can be written as a fraction, so this is a rational number. Okay, and -2 bar notation is also a rational number because it's a bar notation that repeats. But square root of 38, since 38 is 6.1644140, meaning it continues, it's not terminating, it is not a square root or of a perfect square, so it is irrational. Okay, let's try 1a to d. Okay, you can go ahead and try it on your own in a notebook and see if you get them all correct. Pause now and try it on your own. Alright, 0.7, we know this is a fraction of a number, part of a number, so it is a rational number. Okay, 1b, we know that b is a perfect square, 10 times 10, right, is 100. Now it's also a whole number, it's a natural number, it's an integer. So natural, whole number, integer, rational. Okay, 9/5, this is a fraction of a number, it's actually a mixed number too, it could be 1/4/5, right? So it's a mixed number. So we simply say it's a rational number. And -6, it's an integer and a rational number. It cannot be a natural number because it's negative, and it's not considered a whole number because whole numbers are all just natural numbers with the 0. So it's an integer and rational. For example 2, we're going to compare real numbers, okay, where we replace with less than, greater than, or equal to. Okay, and we have two numbers here. Now we have 3 1/3 compared to the square root of 15. How do you find the square root of 15? You have to use your calculator. Here I have the calculator on my phone just to give you an example of how to do it. And let's say I'm going to do the square root of 15. Okay, I'll go to the function key on my phone, and there's the square root sign. Okay, and now I type 15, and I hit equal. So it looks up like that. And then I hit equal, and there's my square root. So 3.87. And you can see that's what we got there, 3.8729. We had all those numbers in our calculator. But when we compare it to 1/3, 3.33, you can see that this number is greater than this number, right? When we look at it on the number line. So since 3.33 is less than 3.81, we write it as with the less than sign. Okay, let's try number 2 here with 7 2/5 compared to the square root of 57. Okay, as I did earlier, I go to my function key. I'm going to press my square root, and I'm looking for 57, and all I do is just press equal, and there I have 7.549. So I'll write it just underneath for myself for my own notes. I have 7.549, I believe I said, and I know that 7 2/5, when I actually convert it to a decimal, 2/5 is decimal 4. Okay, so clearly square root of 57 is larger, so I'll just put that right in there. And now for example 3, we're going to compare and put in order from least to greatest these values. Okay, and you can see that what we do is we convert them all into the same format, which is in this time is whole number or decimal. Okay, so we see here that this one is decimal 8.8. Okay, 8 to the 4/5. Square root of 64 is 8. 8.3 bar notation, it's 8.3333, and so on. And square root 76, when you type that into your calculator, you'll get 8.71, and so on. Okay, and then when you actually put them on a line plot or a line graph, you'll notice which one's least to greatest, and then you put them right back into the same format that they were in. You don't write them in decimal again, you just put them right as square root 64, 8.3 bar notation, and so on. So let's try question 3. Alright, let's see here. Okay, let's put these in order from greatest to least. Greatest to least. The first time I did this, I did it backwards. I did least to greatest, and that is obviously a mistake, so greatest to least. Okay, first I'm going to line them up. Okay, they're not in any particular order, they're just from left to right the way I saw them, and I'm going to convert them all to decimals. Okay, or standard form. Okay, so now we can see that the square root of 30 is 5.477. I stopped writing the numbers because it's fine. We can round to the nearest tenth. Okay, it's easy to round to the nearest tenth here. And then we have 5.6. It's just simply 5.6. 15 divided by 3 is 5, and 5 2/3 is 5.4. Okay, now, oops, I made a little mistake. It's not 5.4. My mistake. It's 5.6. bar notation, right? 2/3 is 6, 6, 6, 6, 6, a bunch. Alright, now we can start picking them off from greatest to least. Remember, greatest to least. So I have my greatest one here, okay? And then because it's 6, 6, and this one is 6, 0. This is a terminating decimal. This is my number 2, so I'm going to put number 1, number 2, number 3 right here, my third one, and my smallest value, number 4, is there. Okay? So go ahead and write it in that order. This is my first one, then my second, third value, and finally my fourth value, which is 5. And there we have it. Okay, by definition of a square root, if x squared equals y, right, then that means that x on its own, not x squared, just x on its own equals plus or minus square root of y. Remember, what we can do is, let's just say x squared equals y. Let's replace the x with 5 squared. You know that would equal 25. Okay, what we're trying to say is that x, okay, when you take away the exponents, is going to equal the square root of y, because 5 equals square root of 25. You see that? And it can be plus or minus, because it can be a plus or minus because 5 times 5 is 25, or negative 5 times negative 5 is still 25. So by the definition of a cube root, if x to the third power equals y, then y is cube y. Okay, cube root y, I'm sorry. Cube root y. Okay? When we just have the square root on its own, we don't have to write the little 2 there, but we do have to write the 3 because it's cube root. You can use these relationships to solve equations involving squares and cubes. Okay, we have a square. We have a square sample right here. Let me zoom that in. And we can do an estimate. If a square is 38, I'm going to think of two numbers that I can multiply to each other that will give me something close. I do 6 times 6. So I know that a is close to 6, but maybe a little bit more because it's 38. Well, it will be a little bit more. So we solve it. We know that a is square root 38, and a is approximately 6.2 and negative 6.2. Because if you multiply negative times negative or positive times positive, you're still going to get a positive answer. So there's your solution. We can say the same thing with a cube. Okay, a cube is going to be the same number multiplied to itself 3 times. And you see here that it's 125. You know that 5 times 5 times 5 is 125, right? And this is the way you would write it when you write it as a cube root. That's a cube root. You take away the cube from the a, and you write it here as a cube root. And you know that a equals 5. Okay, for 4a, we have 363 equals 3 times d squared. So it's a number I multiply into itself. You know you do exponents first. That I can multiply 3 times, and then it'll give me 363. The number I'm thinking about, now you can always isolate the variable, right? So we can bring this 3 over to this side and do the opposite equation. Remember, on this side it's multiplication, so on this side it's going to be division. So now I have something that looks like this. 363 divided by 3 equals d squared, right? And now I know that that's going to be 121 equals d squared. Okay, so now I'm going to continue on up here. Okay, and now I want to remove the square from this side, so I'm going to write it as square root of 121 equals d. And so that we know that the square root of 121 is 11, and that's what d equals. And that's how those are all the steps you can follow to solve these equations. Okay, for 4b we have 729 equals s cubed, and I can now write it as cube root 729 equals s. And when I multiply a number into itself 3 times, okay, and this is only by trial and error. Let's say if I did 8 times 8 times 8, that's going to give me 64. 8 times 8 is 64. Times 8 is 512, so that can't be it. So I'm going to go up by one more, so I'm going to go 9 times 9 times 9. 9 times 9 is 81 times 9 equals 729. So there we go. So I can say S equals 9. Okay, I want you to please try 4C on your own, and as well as 5D. Try those two on your own, and we'll check them in class. For example 5, go ahead and read example 5 because I'm getting close to that 15-minute mark and I don't want to make this into 2 videos, so read that on your own, but let's try question 5. Okay, let's read it. A tsunami is caused by an earthquake on the ocean floor. The speed of a tsunami can be measured by the formula s squared divided by d, or over d, equals 9.61, where s is the speed of the wave in meters per second and d is the depth of the ocean in meters where the earthquake occurs. What is the speed of the tsunami if the earthquake occurs at the depth of 632 meters, so that's d, and then round to the nearest tenth? So we have something that looks like this when we replace the variable d, right? And we want to isolate s, so let's bring this over to the other side. And on this side it's division, but on this side it will be multiplication, so it'll look like this. Okay, this looks very similar to the equation of the line. You guys are going to learn what equation of the line is soon, but this is our constant. This doesn't change, and this changes, so when this changes, it'll change our outcome. It's what we call direct variation. Now here we have 9.61 times 632 equals 6,073.52 when I do that, and that's s squared. So what number multiplied into itself is going to give me something near 60, and then I can just add 2 zeros to it.